بسم الله الرحمن الرحيم. الأستاذ المساعد الدكتور زيد عبد الزهرة حسن، قسم الفيزياء، كلية التربية علوم الصرفة، جامعة بابل. اسم الموضوع Liquid Crystal. Introduction of liquid crystals. Liquid crystal is intermediate from between the crystalline salt and isotropic liquid. It has some special properties. Individual clocks always have an isotropic shape, rod-like, disc-like, dielectric constant, reflective indices. A molecular arrangement was some degree of positional order or rotational order. The molecular arrangement can be affected by external fields such as electric, magnetic, shear stresses, or surface jarring. This figure is being a temperature effect. We see the crystal solid is to liquid crystal and final isotropic liquid. Climatic liquid crystals. The liquid crystal is divided four phases: nematic phase, symmetric phase, and cholesteric phase. Nematic liquid crystal molecules have potential order. The direction can be controlled by alignment film and external field. Cholesteric liquid crystal page length can be changed by temperature and interaction with chemicals. Nematic liquid crystal sensors. We see the sensors is divided for chemicals and using the nematic sensors. Nematic liquid crystal sensors. Nematic liquid crystals can be used to amplify and image transductor, reservoir method binding of protons at surfaces, nanometer scale topographs on the surface. We see the figures could be overwhelmed by the specific binding of protons surface, thus leading to macroscopic changes in orientation of liquid crystal aligned by this surface. Edge and this nematic liquid crystals. When to prepare the liquid crystals, and we see selective binding, analytic, and receptor on the surface can also change interaction between liquid crystal and surface. The resulting optical signal can be easily be observed by naked eye due to amplification by the liquid crystal molecules. Long-range order. Nematic liquid crystals. When the difference between phases. Because liquid crystal molecules have high mobility of liquids, information about the binding, the analytic, and receptor are surface propagated rapidly from surface onto the bulk of the liquid crystal. Transduction and amplification can occur in a few seconds. The lines on the substrate can be diluted to reversible bind with the liquid crystal molecules and analyze. Cholesteric liquid crystals. Cholesteric liquid crystals selectively reflect light of wavelength equal to the page length. Lambda r sub r equal and average multiply page length. Organic fibers can be incorporated between the layers of the cholesteric liquid crystal, changing its page length and therefore its color A glass disc was used in substrate for preparation of the liquid crystal cholesterol films. Its reverse side was masked with black to absorb in scattered light. In order to link the lifetime of liquid crystal sensor decreases a vibration and mechanical driving. The liquid crystal films can also be immobilized in PV poly-filling crystal and silicon rubber. Cholesteric liquid crystal sensor, the optical properties is sensing phase can be done by changing the composition of the liquid crystal cholesteric mixture, altering the sensitivity and selectivity for different organic fibers. The lifetime of the liquid crystal cholesteric layer is not long, it's less than 200 minutes. To overcome this drawback, the liquid crystal films could be encapsulated in polyvinyl chloride or silicon rubber. If the liquid crystal is maintained in small diamonds dispersed in polymeric film. Discotic liquid crystals. We see the discotic pneumatic, discotic laminar, and structure chemical is equal the discotic liquid crystal. Discotic liquid crystal molecules typically consist of an aromatic core surrounded by hydrocarbon side chain. The center of the molecular stack is electron range and reflective conductivity in nature, whereas the outer layer is relatively insulting. Discotic liquid crystal sensor charge carrier can move easily along the columns with relatively high mobility, but charge carrier motion between columns is greatly hindered by interviewing hydrocarbon chain region. Molecules at the surface have many more degrees of freedom and are able to enter coordinational and positional. This leads to considerable conductivity compared with the bulk. AR or R naught is positive for all alkaline hydrocarbons. The tentative explanation is that the alkaline fluid dissolves in the alkyl side chain region of the discotic surface. This reports is rotational and positional of the molecules, thus increasing the surface resistance. The longer the alkyl chain length, the greater the disruption of the fluctuations and the greater measure resistance. The response to saturated water fibers in nickel. The sensitivity to the presence of water primarily due to the hydrocarbon nature of the surface of the discotic liquid crystals. Lytropic liquid crystals. Lytropic liquid crystals such as surfactant can form variety of the liquid crystal phase in solvent. This ordered due hydrocarbon hydrophilic combinations. Most biological responder possess both hydrophilic and hydrophobic region, and thus ready incorporated into bifilling lytropic liquid crystal. One responder lined complex forms. The uniform order is disrupted, producing an optical response. The elasticity of a liquid crystal amplifies the local distortion in viscosity of the responder lined complex and repeatedly expanded to the optically detectable supermicron scale. Lytropic liquid crystal offers a system that repeatedly and automatically detect lines, especially when they're present in very small quantities. As further, the information that multi-well systems, each well having predetermined responder, can be used to detect different kinds of lines. This is compression for tips liquid crystal sensors. Compression for tips liquid crystal, pneumatic liquid crystal, cholesteric liquid crystal, discotic liquid crystal, lytropic liquid crystal, and analysis. Sensor tips, pneumatic liquid crystal, binding of analytic the response change liquid crystal orientation above the surface. Cholesteric liquid crystal, organic fibers can be intercarbonated between the layers of liquid crystal, change their bench length and therefore their color. Discotic liquid crystal, the absorption of volatile will affect potential and positional of the discotic liquid crystal molecules on the surface, therefore change the conductivity. Lytropic liquid crystal sensor binding of lines to the responder housed in lytropic liquid crystal will cause deformation of liquid crystal and elimination of the transmission of polarized light. Sensor tip and special instrumentation for detection. Pneumatic liquid crystal, non-naked eye. Cholesteric liquid crystal using a spectrometer between 400 to 800 nanometer is needed to measure the reflectance spectroscopy. Discotic liquid crystal sensor electrometer you need electrometer needed to measure conductivity change. Last, lytropic liquid crystal, naked eye only. Calculation. 4 types of liquid crystal sensor and their working mechanisms have been introduced. Compared to the bulky and complex spectroscopy, these liquid crystal sensors can not only provide real-time portable detection at responsible sensitivity, but also can be easily operated and magnified. At last, thank you for listening to me.